Assalamualaikum and hi, my name is AZZAHRA binti AMMAR FANSURI. Today I will present to you about the introduction and the history. The environmental problem, exhaust emission regulation and fuel economy standard of passenger cars and light trucks are being introduced on a global scale. Average fuel economy of passenger cars in Japan increased for a while during the bubble economy years around 1990. On the whole, fuel economy of cars has continued to fall since 1975. Number of cars on the road has grown. However, carbon dioxide emission have increased, and effort to reduce the amount of carbon dioxide emission in countries around the world have intensified. The first commitment period of the Kyoto Protocol start from 2008, and further reduction in carbon dioxide emission will be stipulated from 2013 as measured in the automotive field, promoting hydrogen or electrification of cars and facilitating traffic flow by adopting intelligent transport.
Hello guys, my name is Young. Today I will present the CO2 reduction by hybrid and electric vehicles. CO2 reduction can be achieved by hybridization of vehicles. According to the figure, CO2 emission from fuel consumption is reduced by about 50% by switch from conventional engine to HEV. By subsequently switch from HEV to PHEV, the CO2 emission can be reduced by another 70% in fuel consumption. Okay, in total, CO2 emission ratio for HEV and PHEV only differs 6% because electric power generation for PHEV was done by fossil fuels. It can be considered that CO2 emission volume can be significantly reduced by electrification from HEVs to PHEVs and EVs. As a battery for HEV, the lithium-ion rechargeable battery which offer the advantage of high energy and power density and also long life. The first generation lithium-ion rechargeable battery with a power output of 1.8 kilowatt per kg. The second generation is 3.1 kilowatt per kg. Improvement of power density is directly connected to the performance gains by energy generated braking during car running and by power access screen, so it's considered to be effective for improving fuel economy and reducing CO2 emissions.
Assalamualaikum and good day to all. My name is Muhammad MALIK and I will explain on system diagram of HEV and PHEV. Hybrid electric vehicle HEV for the system diagram is located at the left hand side. This system are powered by an internal combustion engine and an electric motor that use energy stored in batteries. It is not possible to plug a hybrid electric vehicle in to charge the battery. Instead, the battery is charged through regenerative braking and the internal combustion engine. The additional power provided by the electric motor may potentially allow for a smaller engine. The battery can also power auxiliary loads and reduce engine idling when stopped. Together, these features result in better fuel economy without sacrificing performance. For the system at the right hand side is a plug-in hybrid electric vehicle PHEVs. The system uses batteries to power an electric motor and other fuel such as gasoline to power an internal combustion engine ICE. PHEV batteries can be charged using wall outlet or charging equipment, ICE or regenerative braking. Typically, the vehicle will run on electrical power until the battery is almost exhausted. Then, the car automatically switches over to use the internal combustion engine again. Thank you.
Okay, hi. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAFIFI binti KAMARUDDIN. My meeting number is B0717100626. Okay, I want to continue about advantage and disadvantage of the system in the journey of the reduction of CO2 emissions for automotive system. Alright, continue advantage and disadvantage of the system. CO2 reduction by hybrid and electric vehicle. The advantage, firstly, according to the figure 2.1 above, CO2 emission is reduced by about 50% by switching from a conventional engine vehicle to an HEV is hybrid electric vehicle, and by subsequently switching the HEV to a PHEV, plug-in HEVs, it can reduce by another 70% through improvement in single battery charge running distance. Okay, in disadvantage, in accordance with the vehicle described above, as the key technology for handling the switch from HEVs to PHEVs and EVs is electric vehicle that will allow longer electric running distance. R&D, research and development on boosting battery capacity, increasing motor and inverter power, and improving heat resistance is still pushing forward in the future. Okay, continue with second advantage is battery technology for HEVs. The lithium-ion rechargeable battery with advantage of high energy density, high power density, and long life are drawing most attention as the main battery of the future. Therefore, the disadvantage for lithium-ion cells and battery are not as robust as some other rechargeable technology. They require protection for being overcharged and discharged too far. However, a major lithium battery disadvantage is their cost that is so expensive. Okay, lastly, from advantage and disadvantage of this system is inverter technology for HEVs. As for inverter for HEVs, in contrast to ones for industrial use, they are almost never in steady operation under red load, and their output power changes as needed in response to driving conditions cornering the car. So this disadvantage is increased powertrain and electronic cooperative, increased vehicle mass due to addition for components, increased cost due to additional components and complexities of the power management. Besides, the overall system reliability can be lower due to increased complexity, and if not optimized for the operative drive cycle, benefit may not be fully realizable. This is all for advantage and disadvantage for this system. Okay, thank you. This is all for me.
Hi, my name is ILIYA bin IDRIS. So we continue with the opinion on future technology and any improvement can be made. So this technology could establish to the automotive industry for future technology and could give a positive feedback on the environment. For the improvement, it could develop a high heat resistant and lightweight packaging for inverter, and also develop a low loss control device and provide solution for electric vehicle. Next one is the energy regenerative braking during vehicle service and through power assist system. This improvement could highly give a power efficiency enhancement, so it could increase the fuel efficiency and lowering the CO2 emission for the vehicle. Next one is the effort on direct injection engine system, which directly inject fuel into the cylinder, and variable valve system which lower pumping loss. For this improvement, it most likely to achieve a high compression ratio and the reduction of pumping loss. It is regulate the injection timing and fuel air mixture delivery freely in the cylinder, which give a better fuel efficiency and high power performance can can be accomplished by maintaining the height compression ratio. Thus, in the future, it is considered likely that this technology will evolve toward path guidance and result in much lower consumption of fuel. So that's all for me. Continue with my next fan. Thank you.
Hi, my name is KOVINTHAN ALAGAN. I will talk about the conclusion. The environmental impacts associated to vehicular emissions are complex and require a simultaneous approach of the three independent variables, which is fuel, vehicle technology, and condition of use. It is necessary to know these triple independence better to be able to establish and prioritize effective corrective measure. That's why this report describes the main approach that is focusing on for reducing carbon dioxide emissions from passenger car, which is hybridization and electrification of drivetrains. This systematic approach to vehicle emissions control will allow for the development of sustainable urban air quality improvement measure in this planet. That's all from me. Thank you.